All right, so let's look at the review number 1. So we're going to solve using Kramer's rule. First thing you want to do when you have a question like this, make sure your terms are in order. Some of the quiz questions had the answer on the other side or the x and the y backwards. You want to make sure it's in order. So when we find our determinant, here they're in order, so we don't need to rearrange anything. So we've got a column of x's and a column of y's. So 3, 4, and -5, 2. Majors minus minors. So 3 times 2 would be 6, minus -5 times 4 is -20. So minus negative would be plus, this would be 26. Next, we want to find the determinant of x. One more thing about the test is you guys can use a calculator. So make sure you bring a calculator for tomorrow, not for the quiz. So for the test, you can use a calculator. To find the determinant of our x, we're going to put the answers in the x column. So 1, 3. Y column stays the same, 4, 2. Majors minus minors, so 2 minus 12 would be -10. And then the determinant of the y, the answers go in the y column now, so 1, 3 goes in the y column. The x's stay the same, so 3, -5. This would be 9 minus -5, or 9 plus 5 would be 14. When we write our answer, it's d sub x over d, comma d sub y over d. So d sub x is -10 over d, which is 26. D sub y is 14 over d, which is 26. Make sure you simplify if you can. Here we can definitely simplify. -10 over 26, we can divide them both by 2. So that would be -5 over 13. 14 over 26, we can divide them both by 2, so this would be 7 over 13. So that would be our answer. So 3, we want to solve using Kramer's rule. Same thing, make sure your terms are in line or in order. Be careful, because looking at our second equation, we don't have an x and we don't have a y, so zeros are going to go in those spots. So to find our determinant, first row is going to be -6, -1, 1. Second row, 0, 0, 4. And the third row, 4, -24, +24. To find the determinant of a 3 by 3, we need to rewrite the first 2 columns on the outside. So -6, 0, 4, and -1, 0, -24. Be careful when you're circling or highlighting your majors and your minors. Some people's diagonals were off. You skipped a number, so it threw off everything. -6 times 0 times 24 is 0. -1 times 4 times 4 would be -16. And 1 times 0 times 24 is 0. So this would be -16 minus, let's find our minors now. Four times 0 times 1 is 0. 24 times 4 times 6. 24 times 4 times 6 would be positive 576. And then 24 times 0 times -1 is 0. So minus 576. -16 minus 576 would be -592. So this is our D. Next, we want to find D sub X. So the answers are going to go in the X column. So -7, -6, and 17 it goes into the X column. The other 2 columns stay the same. -1, 0, -24, and 1, 4, 24. Now we're going to rewrite the 2 first columns in this matrix on the outside. So our 2 new columns, -7, -6, 17, negative 1, 0, negative 24. So majors minus minors. Negative 7 times 0 times 24 is 0. Negative 1 times 4 times 17 would be negative 68. And then 1 times negative 6 times 24, negative 24, would be negative 144. Oh, just kidding, positive 144. So negative 68 plus 144 would be 76. So that would be our major answer minus the minors. Seventeen times 0 times 1 is 0. 24, negative 24 times 4 times 7 would be positive 672. And then 24 times negative 6 times negative 1 would be positive 144. So our minor answer would be 816. So 76 minus 816 be negative 740. So that's d sub x. Let's find d sub y. So the x and the z column are going to stay the same as the original. So 6, 0, 4, and z was 1, 4, 24. And then the answers are going to go into the y column. Negative 7, negative 6, and 17. I'm going to rewrite my first two columns on the outside. Negative 6, 0, 4. Negative 7, negative 6, 17. Major minus minors. Negative 6 times 24 would be 864. 4 times negative 7 would be negative 112. 1 times 0 times 17 is 0. So 864 minus 112 is 752. So that's our major minus the minors. Four times negative 6 times 1 is negative 24. 17 times 4 times negative 6 would be negative 408. 24 times 0 times 7 is 0. So negative 24 minus 408. This would be negative or minus negative 432, which turns into a plus. 752 plus 432. It's 1,184. Lastly, d sub z. So the x and the y column are going to stay the same as the original, so coefficients for the x's and coefficients for the y's. And then the answers are going to go in the z column now. Negative 7, negative 6, 17. We're going to rewrite our first two columns on the outside. Negative 6, 0, 4, negative 1, 0, negative 24. So major minus minors. Majors start with 0 plus negative 1 times negative 4 negative 1 times negative 6 times 4 would be 24. 7 times 0 times 24 is 0. Then minus the minors. would be 0. 24 times 6 times 6 would be negative 864. And 17 times 0 times negative 1 is 0. So we got 24 minus negative 864. This turns into a plus, so we get 888. Big numbers, but it's okay because we have a calculator. Next, let's write our answer. So d sub x over d, comma d sub y over d, comma d sub z over d. So d sub x is negative 740 over negative 592. D sub y is 1,184 over negative 592. And z would be 888 over negative 592. Last thing we want to do is simplify. Don't forget to simplify. It simplifies into 5 over 4, negative 2, and negative 3 over 2. Perfect. Let's do number 7 next. So you want to find the partial fraction decomposition and solve. Just make sure you pay attention to the directions. A lot of people ran out of time on the quiz because they solved when they didn't need to. So just read the directions. First thing we want to do here is factor our denominator. When our leading coefficient's not 1 and we don't have a GCF, multiply the first times the last. So this gives us negative 6. 2 factors of negative 6 that add to 1 would be 3 and negative 2. So we get x plus 3 and x minus 2. What do we have to do next? Divide by the leading coefficient. Divide by the leading coefficient. Again, most of you guys are seniors. You're going to college. You need to know how to factor when your leading coefficient's not 1. This stumped a lot of people on the quiz. If you can't divide, so simplify if you can. If it does not simplify, move your denominator to the coefficient of the x. So 2x plus 3. If it does simplify, simplify. So this would be x minus 1. You can always check your answer if you FOIL this out. You can FOIL it out in your head and see, do I get the original function? Yes. So you can always check to make sure you factored it right. Just FOIL it out real quick, or even at least check the first. That's where most people go wrong. If you don't simplify, your firsts aren't going to end up being that 2x squared. So this would be a over 2x plus 3 plus b over x minus 1. We want to multiply by our missing denominator. So a gets multiplied by x minus 1. B gets multiplied by 2x plus 3. And then set the numerators equal. So this gives us 3x plus 4 equals a times x minus 1 plus b times 2x plus 3. We need to know what we're plugging into the x. So we'd set the denominators equal to 0. We get x equals negative 3 halves and x equals positive 1. So we can start by plugging in negative 3 halves. So negative 3 halves times 3 plus 4 equals a times negative 3 over 2 minus 1. When we plug in that negative 3 halves, it's going to cancel out the b. It's going to go away. So we're just solving for a here. This gives us negative 9 over 2 plus, I need a common denominator if I'm going to add these together. So I'm going to change this to be 8 over 2. That's equal to a times negative 3 over 2 minus 2 over 2. Again, I need a common denominator if we're going to add or subtract. So we get negative 1/2 equals negative 5 halves times a. Now we can divide both sides by negative 5 halves. We'd have to keep change flip because we'll have a fraction and a fraction. Or if you'd want to do it one step at a time, you can do that too. We can multiply both sides by 2. So it'll cancel out with our denominator. And then we can divide both sides by negative 5. So we get negative 1 over negative 5, which would be 1/5. So a equals 1/5. We're going to do the same thing to find b now. So next we want to plug in x equals 1. So 3 times 1 plus 4 equals, when we plug in 1, the a is going to go away because 1 minus 1 would be 0. 0 times a is just 0. So b times 2 times 1 plus 3. So this gives us 7 equals 5b. Divide by 5. b equals 7 over 5. Last thing we want to do is plug it into our fraction. Make sure you plug a into a and b into b. I've said it 100 times. Every single time we do this, I remind you, plug a into a and b into b, and people still mix them up on the quiz. Numerator stays in the numerator. Denominator goes to the denominator. So for a, we have 1 over 5 times 2x plus 3. Then for b, so plus 7 over 5 times x minus 1. So you guys are not given Pascal's triangle. You need to be able to come up with it. So to come up with Pascal's triangle, we're going to start with our little triangle of 1s. Every row is going to start and end with a 1. We're going to add the 2 numbers above it. So our next row would be 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This, for number 10, we're looking for the 5th row, so we need one more. 1, 5, 10, 10, 5, 1. So the 5th row is going to be the row where the second number is 5. It's going to be the row that's got the 5 in it. So our coefficients that we're going to use are 1, 5, 10, 10, 5. 1. Next, we need our first term, which is 3x. So 3x is going to go in each column. We're going to start with 3x to what power? To what power? The 5th power. So 3x to the 5th power, and then we decrease from there. 3x to the 4th, 3x to the 3rd, 3x to the 2nd power, 3x to the 1st power, and 3x to the power of 0. Then our second term is 4. So each column is going to get its own 4. I'm going to start with 4 to what power? 4 to the power of 0. Perfect. And we go up from there. 4 to the power of 1, 4 to the power of 2, 4 to the power of 3, 4 to the power of 4, 4 to the power of 5. Now let's combine our columns. Be super, super careful. 3x to the 5th power, that 5th power gets distributed to the 3 and the x. And what's 4 to the power of 0? 1. So I like to just cross off the power of zeros, get them out of the way. So 3 to the power of 5, we can put it in our calculator. 3 to the power of 5 would be 243x to the 5th power, times 1 would just be 243x to the 5th power. Next, I need to distribute the 4. So we have 3 to the 4th power. 3 to the 4th power would be 81 times x to the 4th power. So we have 5 times 81 times 4. 5 times 81 times 4 would be 1,620 times x to the 4th power. Same thing with our next term. We got to distribute the third power. 3 to the third power is 27 times x cubed. And 4 to the second power is 16. So 16 times 27 times 10. Is 4,320 times x to the third power. Again, we need to distribute. This is 9x squared. 4 to the third power is 64. So 64 times 9 times 10 would be 5,760 x to the second power. Here we just have 3x, 4 to the fourth power would be 256. So 256 times 3 times 5 would be 3,840x. And then lastly, 4 to the fifth power would be 1,024. So this would be our answer. Any questions? Next one I want to do is number 12. So we're going to expand using Pascal's triangle. We're looking at the fourth row of Pascal's triangle. We'll write it again just to practice. But if you want to, go back and scroll to the one that you wrote before. So we have a triangle of ones. Then 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. We're looking at the fourth row, so the row that has 4s in it. So 1, 4, 6, 4, 1. Then each column is going to get 3x squared. 3x squared, 3x squared. So we start with 3x squared to what power? To the fourth power. 3x squared to the third power, 3x squared to the second power, 3x squared to the first power, 3x squared to the power of 0. Next row is going to get our negative 2y cubed. So negative 2y to the third power, negative 2y to the third power. And we're going to start with which exponent? 0, and then go up from there. So it's the power of 0, it's the power of 1, it's the power of 2, it's the power of 3, it's the power of 4. I like to cross off to the power of zeros, just get them out of the way. We know that anything to the power of 0 is just 1, so just get rid of it. Now we can't forget to distribute our exponent. 3 to the fourth power would be 81. And then x squared to the fourth power. When you have a power raised to a power, what do? Power raised to a power. We multiply. So this would be x to the 8th power. So our first term is 81x to the 8th power. Let's do the same thing with the next column. Distribute the third power. 3 to the third power is 27. Then we have x to the, what power here? To the 6th power. 2 times 3 would be 6. And then when I distribute the first power, it's still negative 2y to the third power. So we have 4 times 27 times negative 2. 4 times 27 times negative 2 would be negative 216 x to the 6th power, y to the 3rd power. So remember, when you have two variables, just keep it in alphabetical order. Put the x's first, the y second. Then, next term, we're going to distribute. So 3 squared would be 9. X squared squared would be x to the 4th power. Again, we want to distribute here. Negative 2 squared would be 4. Y to the 3rd power squared would be y to the 6th power. You multiply power to power. So we have 6 times 9 times 4. So this would be positive 216 x to the 4th power, y to the 6th power. Next, we want to distribute here. Negative 2 to the 3rd power would be negative 8. Y to what power? Y to the 9th power. Perfect. So 4 times 3 times negative 8 be negative 96 x squared y to the 9th. And then lastly, we got to distribute the 4th power. Negative 2 to the 4th power would be positive 16. What's y cubed to the 4th power? Y to the 12th power. Awesome. So this would be plus 16y to the 12th power. So this is our answer. Remember, we said if we just have a minus in the middle. So if you have a binomial with a minus in the middle, your signs are going to alternate. Starts positive, negative, positive, negative, positive. So you can always check your work that way. But that's only if you just have a minus in the middle. If you had a negative out front, if that was a negative 3x squared, it'll throw off the signs, so it doesn't alternate. Not that it doesn't, but you just have to be careful with the signs if you've got multiple negatives going on.